Thank you for visiting our website and taking the time to learn more about BioReactor Sciences. This presentation will outline how our packed bed bioreactor systems are unique and innovative, and how the roller bottle principle is applied, contributing to our proven formula for superior cell culture production. For the growth and production of biologics, vaccines, and cells, adherent cell cultures require attachment to some form of carrier. Attachment to microcarriers or beads have traditionally been the most popular method for this application. In recent years, however, packed bed systems with advantages in cell attachment, medium replacement, and high cell density have grown in popularity. Packed bed systems have many advantages over traditional microcarrier systems. Firstly, packed bed bioreactors have a stationary bed packed with cell carriers on which adherent cells easily and efficiently attach. This is in contrast to microcarrier systems where the carriers freely float throughout the vessel and are under agitation. Secondly, the cells are immobilized, embedded, or attached to the carriers, facilitating easy replacement or replenishment of media. Thirdly, the cells are confined in the carrier bed and are thus protected from shear forces. Our packed bed systems have many unique and innovative features. Due to our patented design, our packed bed bioreactors can adjust to the very minimum volume of media, virus, or enzyme treatment for complete cell submersion. This in turn equates to high efficiency of cell attachment, virus infection, DNA transfection, and enzymatic treatment for cell detachment. Furthermore, our moving packed bed MB systems allow for cell detachment and recovery all in one vessel. Most importantly, the application of the roller bottle principle further enhances the unique features of our systems. Utilization of this principle or system, which mimics how oxygen and nutrients are transferred to cells in roller bottles, results in no requirement of agitation or aeration, generating little to no shear stress in the cell culture. This in turn leads to no scale-up and no foaming issues. Up until now, roller bottles have been one of the most popular bioreactors with adherent cells for vaccine and biologics production. The roller bottle principle is the system illustrating how oxygen and nutrients are efficiently transferred to cells. Cells attached to the roller bottle walls are intermittently and gently exposed to air and submerged in media. Oxygen is transferred directly from the gas phase to the cells. This low shear environment is attributed to no required agitation or mixing. With their limited surface area, roller bottles, however, have limitations like low yield, are very labor intensive, and require a large physical footprint, mostly in the form of cleanrooms. Packed bed systems address these limitations with stationary beds or matrix chambers filled with cell carriers that result in high cell density. The roller bottle principle is applied to our bioreactor systems because it is simple and reliable. With its gradual in and out movement of media, cells are alternately and mildly exposed to air and media. The media's deliberate motion results in little to no shear stress, resulting in no foaming issues. And because there is no requirement of aeration or agitation which is scale dependent, our systems have little to no scale-up issues. If the environment and conditions surrounding all the cells of a cell culture can remain the same from small to large scale, then the cell culture should behave the same regardless of the scale of production. This eliminates any issues and challenges of scaling up. The roller bottle principle applied to our bioreactors means that no matter what size or scale the system, the simple surrounding conditions of the cell culture will remain the same because there is no involved agitation or aeration. In a conventional bioreactor that requires agitation and or aeration, surrounding conditions of the cell culture are unable to remain comparable as it develops from small to large scale. The cell culture will then behave and perform differently, making scaling up in conventional bioreactors difficult. Our packed bed bioreactor systems can again be easily scaled up due to employing the roller bottle principle. Owing to this principle, our systems do not require agitation or aeration, which translates to little or no shear stress. Additionally, all of our systems, regardless of size, have similar bed heights, cell exposure, and submersion cycle times. This further enhances environmental similarity among different scales or sizes of production. Accordingly, cells cultured in our systems are exposed to the same surrounding conditions from our dish size to larger scale MB and FB systems. The application of the roller bottle principle and its advantages of no scale-up issues is illustrated with our progression of packed bed systems. BioReactor Sciences systems that employ the roller bottle principle range from the mini small-scale MBDH dish system, the benchtop lab-scale MBBX box module system, to our larger pilot plant and industrial-scale MB, MBS, or FB, FBS systems. The FB and FBS fixed bed bioreactor systems have its respective carrier beds fixed in a stationary position. The roller bottle principle is facilitated as the medium flows in and out of the bed via pneumatic means. The FB system is a stainless steel system with the carrier bed inside the vessel. The FBS system is a single-use system with a separate carrier container and a medium bag connected via flexible tubing. This slide illustrates how the roller bottle principle is implemented in our FBS single-use system. The slow movement of the culture media and the carrier bed or cell matrix provides an optimal supply of nutrients and oxygen to the cells. Because the cells are embedded on carriers inside of the matrix, in for example our BX module, they are protected from what little interference or shear stress the media may present. Our MB moving bed system is similar to our fixed bed systems in that they entrap the cells in a carrier-filled bed. The packed bed, however, is movable, allowing for the maximum flexibility in using the minimal amount of seed, virus, DNA, and cell detachment enzyme. This flexibility results in maximum efficiency of cell attachment, infection, transfection, and cell detachment or cell recovery. From our lab scale to production scale systems, the moving bed easily facilitates the roller bottle principle, be it in the form of our controllable rocker or pulley system. The roller bottle principle is implemented in our MBDH moving bed dish bioreactor through the lab rocker's up and down motion. This slow and deliberate motion allows for cell carriers in the petri dish to be exposed intermittently to media and air. The MBBX moving bed box bioreactor system also employs a digital, fully controllable rocker to perform the roller bottle principle. In our BX box module, the carrier bed is placed on either end of the box, or optionally, 2 high cell density carrier beds can be placed on each end. As the rocker tilts side to side, the carrier bed is gradually exposed to air and submerged in media. The MB100 and 200 moving bed bioreactor systems consist of a reusable vessel that houses a moving basket holding the carrier bed. As the basket moves up and down, the carrier bed is intermittently exposed to air and media, implementing the roller bottle principle. This mobility further increases the bioreactor's functionality for cell attachment, virus infection efficiency, and cell detachment and recovery. The MBS 100 and 200 moving bed bioreactor systems are single-use systems. They consist of a set of single-use box modules, our BX box module bioreactor, placed on a moving platform, and a single-use bag for medium. The set of BX box modules are connected and arranged in series, all connected together, into the medium bag with flexible tubing. The set of BX modules placed atop the moving platform then moves up and down by our motorized pulley system, facilitating the medium flow and the roller bottle principle. Applied to our packed bed bioreactor systems, some of the exclusive elements in employing the roller bottle principle include extremely high oxygen transfer capability due to maximum and direct exposure to air, and near independence of scale factor in terms of oxygen transfer attributed to no required bulk mixing of liquid media, resulting in extreme ease of scaling up. And unlike other systems, there is little to no shear stress, proceeding to no cell damage and foaming issues. All combined, these qualities make BioReactor Sciences bioreactors the most ideal application for superior cell culture production. Thank you again for taking the time to learn more about BioReactor Sciences and our unique and innovative packed bed bioreactor systems.